think this should go pretty easy since this is awfully similar to what we did in 7.2. Now, I can't remember which class. Was it this class that nobody had really started 7.2?
Yeah.
Okay, so a lot of you hopefully have done your homework by now, that you would know which questions you might have ran into that didn't really click or make sense. Technically, all of the questions in 7.2 kind of needed this method. So I basically taught it last Wednesday, Thursday already, just because I didn't want you to have to learn a different method that would be useless first. And so this is called separation of variables.
You said that we couldn't do,
There was two questions you semi couldn't do.
You're saving 11 for today.
Yeah. So I'm going to kind of teach you the weird part of separation of variables because sometimes it doesn't work out well. And that's really all we want to run into. I believe this is going to be part of 7.4 as well. So there's a good chunk of questions in integration that are based off of this phrase. So the rate of change of y is proportional to y. And I don't know where you're going to write this down, but you'll probably want to write it down. I mean, I guess you could do another sheet of paper and staple it to it or put it in your binder, I don't know. But I wanted to add this because I know this has been emphasized on quite a few AP tests. It's not necessarily hard either, it's kind of a weird phrase. Like, it doesn't necessarily click or make sense right away. So rate of change of y, we would kind of assume that once you see the word rate, that's the derivative. Rather than writing y prime, which isn't wrong, but rather than writing y prime, I'm going to write dy dx or dy dt, depending on the situation. This phrase is traditionally dedicated to word problems, like real life problems, and so if that's the case, it usually has something to do with time. So dy dt is honestly just as common as dy dx. Do you remember what the proportional meant from a couple sections ago? I think it was 7.1. So you guys had proportional and inversely.
I mean, I just think it's just the K, right?
Yeah. So K is the proportional portion, and then this implies directly proportional. For whatever reason, they frequently don't write the word directly. So directly proportional would mean you multiply by y. So this phrase that's going to come up in a lot of the free response questions, I shouldn't say a lot. It usually is one free response question because there's only 6 that they cover like for the entire school year of Calc. So one of the free response questions will most likely have this phrase written in it somewhere. And if it does, it's kind of telling you how the problem or how the equation is going to be set up without actually telling you the equation. Now, our goal at some point here is to find a solution to this. And depending on the problem, it might be a general solution, might be a particular solution. General solution means plus C. Particular solution means you figure out C. So solving that, though, the solution, means you're going to have to integrate. Now, the issue here is we can't integrate the way it's sitting. Because this one that says dy divided by dt, it's not necessarily allowed. We got multiple variables going on. So this is what we went over quite a bit in 7.2. So the method of moving things to the correct place is called separation of variables. So before I integrate, I actually have to rewrite this so things are grouped together. So I'm going to multiply both sides by dt. Whoops. And then I'm going to divide both sides by y. And I can write dy over y, or I could write 1 over y dy. It really doesn't matter. They're both the same thing. And I can integrate this because I've got things grouped together. The k doesn't really matter where you put the k. It's just a regular number, so it really doesn't matter where it goes. Most people will leave it on the t because it's easy to integrate with that. Are you guys okay integrating the right-hand side? Like it's honestly supposed to be the easiest possible thing to integrate, but sometimes that's the hardest. Like it's just hard to picture. They may think they know it without me like calling on people. I mean, I'm hoping this is easy, but I don't know. Sure, Ryan?
So you said the left side or the
Right-hand side.
That's 30.
Yeah. So this is, pretend this is like a 5. If you're integrating 5, we would get 5x. So if there's a k there, it represents a number. So it's just going to be kt plus c. The plus c can go wherever you want. I could write it on the left if I wanted to, but you just need it one place in the whole line. Usually everybody just puts it on the right-hand side. Now this is technically a general solution. The issue is you're never going to see this as an answer. So a general solution usually means it's solved for a variable. And so in that case, like if this is a multiple choice question, they would want it solved for y if you can. So this answer isn't wrong, you're just never going to see it anywhere. So you guys are going to have to solve for y. This was what I think number 11 was in the homework. I know a couple of you came up and asked me about it. If I want to solve for y, which is inside the natural log, I have to take it out of natural log form. So this is like saying log base e. So I'm trying to remember how you guys did it in pre-calc. I feel like in pre-calc, did they have you guys do this? Is that how they told you to take it out of log form? Do you guys even remember anything about logs? Oh, it was like this probably?
Yeah.
Okay. See, I was never taught this method, but it seems like that's kind of how most of the pre-calc teachers do it now. So e to the natural log kind of cancels out essentially, and you'd be left with absolute value of y equals e to the kt plus c. Technically removing the absolute value symbol would make the right-hand side plus or minus. %, if I've lost you at any point along the way, just stop me and I can explain things too. I realize this is Monday after quite a few days off.
Why does the absolute value make the other side plus 1?
Let's say we write that, which has nothing to do with our problem. The x could be positive 5 or negative 5 and still have an answer of 5. And so if you remove an absolute value symbol, what you generally end up doing is just putting a plus and minus in place of it, kind of. So that's where the plus and minus comes from. I know a lot of those things you guys were kind of taught in Algebra 2, but maybe at the time you just didn't really catch on to. Here's the weird part of the problem, because I would love to just tell you we're done. They won't ever leave it like this. So this is one of the properties from powers, exponentials. If you have two of the same base being multiplied, you can add their powers together. So we're doing this in reverse. We're taking one that had a power that was added and going to write it as multiply instead. E to the C, any kind of a numeric operation involving the constant kind of just absorbs into the constant. Because you're trying to find out this number at the end anyway, like say C ended up being 2, you would end up just doing E squared anyway, like you wouldn't actually say it's 2. You would do E squared, which is whatever, like 5-ish. So E to the C becomes C. So rather than finding the C as a 2, you would find the C as the 5-ish number instead. Anytime you have a numeric operation on the constant, it just gets absorbed into the constant and just rewritten as C. So over here in red, instead of writing e to the kt plus c, this is going to be written as c e to the kt. And that plus and minus is no longer there either, because c is a number you're going to find out on its own at the end of the problem anyway. So this ends up being the general solution that you would use. I shouldn't even say use. That's the one they like. It's kind of an annoying fact for me, just because I don't have an issue with that one up top, because ln of y equals kt plus c seems decently simple and straightforward on its own too. Now, I know a lot of people like this because it's solved for y, but I don't know, it's an awful lot of work to go from there to there. So question 11, you guys had one that was similar to this. You actually had a number in place of k, I think, or maybe that one was like x plus 4 or something. You had one that was actually very close to this problem in number 11 in the homework for 7-2. And that's why I didn't think you should need to do it yet. I wanted to show this example first because this portion right there is going to be kind of frequent in your problems. You're going to have to know how to solve natural log of y because you run into it more than you'd expect. I mean, like, there's quite a few topics that involve it. How fast something cools off, radioactive carbon dating, Richter scale, decibels. Like, there's a lot of topics that just end up involving ln, and that's where it comes from. Okay. So here's our actual notes. I thought it would be easier if we did that problem first because it's involved in some of these. You guys look pretty well lost or dead or what? You guys have zero questions on anything? Is this that easy or are you just that disinterested?
Makes sense.
Both? Feeling burnt out or what? Technically, we haven't had anything for quite a while. And not only that, we have nothing tomorrow, and we only have one day on Wednesday or Thursday. I believe we have school this Friday, correct? That's right. The Monday after is off? It is not flex day as far as I know. I think the last flex day is in May. May 13th? Okay. Yeah, apparently they built in the flex days for next school year too. They released the calendar, and I'm kind of surprised at that, to be honest. I didn't think they would do those next year. Unknown. I wouldn't be surprised to see wind days next year. I'm assuming this year's kind of like a test pilot. There's actually a lot of schools that do that already. Like they've been doing that for quite a while. Like I'm pretty sure Cretan's done it for quite a while. South St. Paul's doing it. Yeah, I don't know. There's benefits and drawbacks of it for sure. But I wouldn't be surprised if they do it again. Okay, should we call on people? Will that help a little bit? No? Whoa, why is that so bad today? You just want to start the homework. We haven't even done a single question, though. Okay, should we start easy? Should we start hard? Easy. Okay, let's do A. Let's try solve A. Find the general solution. Okay, so our goal to find the general solution is to integrate, and we can't because things are in the wrong spot. So I need to shift them around, move them so that y's are together, x's are together. Multiply by y, so this would say y dy. Multiply by dx, so this would say 2x dx. Okay? So, I mean, we basically ended up cross-multiplying. Not that we will usually do that, but... Oh, perfect. This is the other... This one's not hard to do, but I was going to say you don't always solve for y. This is a good example of y. That's a terrible pun. It was unintentional. Who should we go with? Andy? Can you help me integrate? Sure. All right, thanks. So this is y to the first power.
Yeah. Y2 over 2.
1/2 y squared.
Yeah.
Y2 over 2 is fine. Okay, how about right-hand side?
Who's the x squared?
Yep. Plus c. All right. Well, this is technically the general solution, but you generally try to solve for y if you can. So I would multiply everything by 2. And then I do multiply the c by 2, but any kind of a numeric operation on c just stays c. I'm not going to finish solving this one because if I solve, then I would have to have a plus and minus. And usually, if you have to have a plus or minus, they don't generally have you do that extra step. It's usually the form that you'll see. So there isn't any difference, but the goal is usually to solve for y if you can. This is usually the only instance when you can't because you get a plus or minus. So we would stop there and say that's the general solution. If it really bothers you, well, then you could do plus and minus, but you'd have to do plus and minus on the whole thing. Okay, let's go notch harder. C is awfully close to the one we just did. Oh, let's go to D. That definitely looks harder. Thoughts on what we should do first? Sure.
You could rewrite the y prime as dy over dx. Like this.
Definitely true. If you look at A, B, and C, how are the equations set up to start
Set up
with?
equal. So you could move over the 3 e to the x to the side. Sorry.
Yep, the first three are kind of set up so that it's dy, dx, or whatever variables is kind of by itself. So most of these are going to be set up where the rate of change is solved for. So we've got 4y, y prime, which we can write as dy dx, equals 3e to the x. And then because some of the variables are in the wrong place, then I would multiply. Oh, when you're doing separation of variables, you can only do multiplication and division. So separation of variables won't work if you have to like add or subtract something. How should I say that?
So you can't do like minus dy dx. What is that?
Correct. So the main issue is that you have, when you're integrating, you want to integrate something dy and then integrate something dx. And frequently, if you add or subtract at some point in the problem, that plus or minus information wouldn't have a dy on it or wouldn't have a dx on it. And so if you have plus and minus information, it generally needs to be in a parentheses, like grouped together, and so that it won't come apart. I doubt you're not gonna see any questions where you'd run into that, but just letting you know, you can only multiply and divide. Okay, so I'm gonna multiply by dx. So I'll say 4y dy is 3e to the x dx, and then integrate to solve. What do we have? 2y squared. So add 1 to power, divide by 2. 3e to the x. If I integrate that, it's also 3e to the x, which feels wrong, but it's correct. And at this stage, I don't even know what's considered more correct. This feels like a nice, clean answer to me. If for some reason, whatever you're looking at to solve, like if it's multiple choice, like they might divide by 2. It's kind of just prerogative of whoever writes the question, I guess. Okay, I feel like we can go on to the next page. And I think we should do at least one of these. Yes, no? Okay. It is kind of weird that this section only has 2 pages in the notes, where like most of the time our notes are like 5, 6, 7, 8 pages long. Now obviously the one on the bottom, it's only going to be considered harder because it's annoying to integrate and solve. It's not actually harder to work with. I kind of want to do 4 because that one sort of looks the worst to me, in my opinion. Or at least like it might have portions that are tricky for you. Who should we go with? Should we go with, who haven't I called on forever? I haven't called on Kate forever. Kate, what should we do on 4? What should we start with? What did we start with on all the other ones when we were trying to find a general solution? Okay, I was trying to think of like a phrasing to this. Yeah, so finding the general solution means we want to integrate, and so right now we have letters in the wrong spot. So multiply by dx, okay. I like writing it at the end because then I kind of like know it's different or know it's apart, but it really doesn't matter. Anything else, or should we just integrate from there? Or do you want somebody else to go? Okay. Do you want to pick that other person? Lucas? Would you integrate right here, or is there something else we have to do, or?
You multiply by y.
Okay, so this y is kind of in the wrong spot. So we have to have all the x's together, all the y's together. And this one is okay because you can get rid of it by just multiplying. Yeah. Okay, so y dy. 1 plus x over x dx. I'll spot you the integral symbol. Do you want to keep going? Do you want somebody else to go?
We can try to keep going.
Okay, excellent.
So, integral of y dy would be 1/2 y squared.
Yep, perfect. I don't know why, but when it's just like a regular letter, it feels more difficult to do generally. It's hard for your brain to put together that this is power rule. Yeah, no, that's good. Right-hand side, this is the whole reason I wanted to pick this question because, not that it's hard, but it's different. It's not obvious right away. No, that's okay. That's why I picked this one because, like, it feels like it's simple enough to be able to do something. Ryan, are you trying to answer?
Yeah.
Well, what would you do?
I split up 1 over x and then x over x. So split up the numerator.
Okay, that sounds like a good plan. So 1 plus x over x in its current form doesn't really work because the top isn't the derivative of the bottom, so it's not natural log, and it's not really, doesn't really fit anything else that we know of. So one thing we did frequently is if you have a single term on the bottom, is you split apart the fraction so that you can either bring the x up to the top and multiply it out, or you just split it apart. And this works out pretty well because then you get that. Good. So integrating 1 over x is ln of x. Yep. And then integrating 1 is x. And I guess that 1/2 sort of halfway bothers me because it just doesn't look very clean, but it's not wrong. So you could leave it like this line, or I can just multiply everything by 2. And again, natural logs can be really annoying on multiple choice. I can almost guarantee this wouldn't be the answer on multiple choice. The answer would probably be ln of x squared. And I don't need absolute value anymore because it's squared. This is probably the answer you would see on multiple choice. If this were free response, 100% all 3 of these would be correct. Free response is generally your choice on how you want to show the answer. As long as you did the work correct, it's your choice. Okay, Aiden, are we done? I guess that we should probably ask that.
No, we have to satisfy the conditions.
True, what does that mean?
We have to coordinate 1 for y.
Yeah. So we want to figure out C. That's a really weird way of writing that, though. Y of 1. So that means we put 1 in place of x and get -4 as an answer. Usually they only write it that way if it's function notation. Okay, so -4 would be the answer for y if we plug in 1 for x. And I know I ran out of space, so I'm going up. Ln of 1 squared is ln of 1, which is 0. So C is 14. And then our particular solution actually, oh God, I was halfway 14. Here's what's really annoying. Your C value is going to be different depending on which one of these three answers you pick. If I would have picked this previous one, well, actually that one still would have been 14. If I would have picked this one, then the C value would have been 7. So it matters which solution you plug it into or you use to write your final answer. I mean, it's still correct, it's just annoying. I don't even know what the answer key that I gave. I didn't give you this answer key yet, did I? I don't think I created a folder in Schoology for this yet. I guess we'll do that right after this. Okay, I don't even know which answer is in there, but do know there's lots of correct answers. And I know that's where some of you are getting thrown off lately when you've been checking answers in the answer keys. There's lots of ways to write the correct answer. Okay, that's the only two kind of problems in this section. You're either going to find a general solution or a particular solution. Both are found the same way. You move the variables around and then integrate. Okay, I'll stop there. We actually have time to work today.